we're going to talk about electric shock and some precautions you need to be aware of, not just for the exam but for real-life applications of welding as well. The hazard of electric shock is very important to be aware of in welding, as it can cause injuries, fatalities, or even death. To demonstrate how the welding process can cause electric shock, we will discuss the basic diagram of a welding process. Various welding processes follow electron flow. When the electrode holder is not in contact with the workpiece, the circuit is now open with an open circuit voltage of 100 volts. When the electrode is in contact with the work, the circuit is closed. When the circuit is open, that is when accidents happen. Most electrical cutting and welding work is powered from AC sources from 115 to 575 volts. Most welding is done with less than 100 volts. Fatalities though have been reported at less than 80 volts. In relation with this applied voltage, shock currents greater than 6 mA are called as primary because they can cause direct physiological harm. Anywhere between 0.5 mA and 6 mA are called as secondary shock because they can only cause involuntary muscular reactions and not cause direct physiological harm. So again, when the circuit is open, that is where the most danger of electric shock can happen. When there are large amounts of work, it is expected that large open circuit voltage will be required. Automatic controls to reduce open circuit voltage shall be employed. In relation with the above, insulation and standard operating procedures shall be incorporated in the work. Just like any safety program, proper training is essential for safe operation of equipment. Since water is an excellent conductor of electricity, all equipment must be kept clean and dry at all times. Welding terminals must be shielded to prevent accidental contact for other metals such as vehicles, cranes. Mechanical means such as receptacles, recessed opening, and insulating sleeves can be used. This is to prevent those metals from conducting electricity as well. Good electrical grounding shall be in place. Work lead is not the grounding lead. The work lead, that is the cable that is connecting to the work, should not be used as the grounding lead. It should be separate. Electrical connections must be tight and checked. Equipment cables, fuses, plugs, and receptacles must be within their current carrying capacity. This is to avoid compromising the cables that might also damage these cables and cause fire. Welding leads shall be flexible as the work may require going to confined spaces that may require manipulation of the welding lead. Flexible cable will reduce damage done to the insulation as well. Welding should not allow metal parts of electrodes touch the bare skin. This is where wearing of PPEs are essential to prevent accidental contact. Welding circuit must be de-energized to avoid electric shock while the electrode, torch, or gun is being changed. When the torch or gun is being changed, the circuit is now open, so it is necessary to de-energize the machine by pulling the plug from the power source. Once a welder leaves the workstation, the welding machine must be turned off. Similar with the above, once a welder leaves the workstation, the welding machine must be turned off to prevent contact with the open voltage. And that ends this lecture regarding the electric shock.